Welcome to the Power of ERDC podcast, where we explore how science and engineering deliver real-world impact for the nation. I'm your host, Shelley Tingle with the U.S. Army Engineer Research and Development Center. In this episode, we're joined by Brooke Divan, a research physical scientist with the U.S. Army Engineers Paint Technology Center of Expertise, which is located at ERDC's Construction Engineering Research Laboratory. Brooke's work sits at the intersection of research and operations, ensuring coating systems perform as designed and protect critical infrastructure. Welcome, Brooke.
Thank you.
And so good morning. So we're going to jump right in. How can you introduce the Paint Technology Center and its role within ERDC?
Sure. The Paint Technology Center is USACE's technical center of expertise for paints and coatings for military and civil works infrastructure. A simple way to describe this is that we help make sure that USACE's critical assets are protected from corrosion for as long as possible in the field. Our team supports 5 core functions, including research and development, field support, guidance and criteria, training and education, and quality assurance paint testing. We connect the science, the specifications, the contractors, the inspectors, and the owner so that coating systems perform the way they are designed to in the field. Districts and project teams come to us for help with coating selection, specification reviews, troubleshootings, failure analysis, and applying coating requirements in the real world, which sometimes can throw us some curveballs.
And so what problem does your team solve for districts and infrastructure owners?
Corrosion is the largest threat to long-term infrastructure performance, especially for steel exposed to water, chemicals, weather, abrasion, and decades of service with uncertain maintenance cycles. A coating system is the first line of defense against corrosion, and when it works, it quietly protects the structure for many, many years. However, when it doesn't work, the consequences can be expensive, disruptive to operations, and sometimes are quite challenging to fix. Our team supports projects cradle to grave, and that may include helping select the right coating systems early in design, reviewing specifications, answering construction questions that pop up along the way, training applicators or even our USACE QAs, testing coating materials before they are used, and investigating failures when something does go wrong. Our goal is always to prevent problems before they happen, and failure analysis is an important part of our work, but nobody is excited when we have to get involved in that stage. So hopefully we're involved before that. It can help prevent some of those problems from coming up at all.
So you mentioned how it impacts the life cycle. Can you explain a little bit more about that? How does coating performance directly impact infrastructure reliability and life cycle cost?
Sure. One of the clearest examples is going to be on the civil works side. So we're talking about our locks and dams, our hydraulic steel structures. Many of these structures were built in the 1930s, right after the Great Depression, when FDR was, putting into place these programs of getting people back to work. And part of that was to build a bunch of navigation structures on the Mississippi River. And these structures were designed with a service life of 50 years. At this point, we are well beyond that 50 years, but those structures are still operating. They're still moving navigation traffic up and down the rivers, and they're still supporting the national economy. For hydraulic steel structures, coating performance is directly tied to the reliability of the use of that structure. If a gate, a bulkhead, sector, miter, roller gate, tanner gate, or stop log does run into problems with functionality due to corrosion, you can't really just take it out, fix it, and put it back. It's much more complicated than that. Dewatering is expensive, Access is difficult, and mobilization of all the equipment to conduct field repairs on a river with ever-changing weather conditions, it's challenging. Um, and so outages can affect navigation, flood risk management, and project operations. When you're talking about recoding just one large Tanner gate, it can cost on the order of $1 million on average. And USACE maintains hundreds and hundreds of those. Um, we have them all across the country. I would estimate well over 1,000 Tanner gates on USACE infrastructure. So even these small improvements in coating life can translate into major life cycle cost savings. So when we talk about coatings, we are not just talking about making the paint look nice or look pretty when you walk by the structure. We're talking about keeping our critical infrastructure functional, reducing the maintenance outages, extending service life, and then making smart use of the limited maintenance dollars that are available.
And that's what we all like about this technology is it's at the end of the day, it's saving the taxpayer money because we're extending the life of these structures that are well past their life cycle. So, paint us a picture for a moment of what your support looks like during a project from planning through execution.
Well, we like to start our support very early when we get the opportunity, and sometimes before a project is even advertised or put out for bid. The sooner the better, as we can help guide the project to favorable outcomes if we are involved earlier. We may help a district determine what coding system is appropriate for that exposure environment, whether the work is new construction or maintenance on some of these really old structures, what surface preparation could be required, and what type of inspection or quality assurance requirements need to be included in that specification to make sure that we're getting high-end deliverables. Fieldwork is always unexpected and the conditions are ever changing. We run into things you wouldn't even imagine. For example, one of the projects I was working on, we were looking at, we were fixing miter gates on a lock in Florida. But unfortunately, the manatees there decided to flow into the lock chamber occasionally. And when they did, we had to call the proper channels to get them to move on their merry way without us hurting them, which then made us run into problems with our recoat windows. So some of the challenges aren't super visible at face level, and you have to really kind of investigate the actual project and help on the spot to develop solutions. During design, we often review specifications or help answer RFIs, which are requests for information that come in from the field. During construction, the questions can become really practical. What do we do if the steel we blasted yesterday is now rusted because it rained overnight and our containment didn't hold? Or what do we do if the recoat windows are exceeded due to manatees being in the way and we need to safely get them to move along their way? How should the stripe coats be documented? What is an acceptable surface profile if things aren't going smooth and we run into an issue with the equipment? So all of these things are very important. And if we don't have an answer, we love to speak with the other experts to make sure that the overall plan is collaborative and looks at these issues from many perspectives. For example, I can give you the very best paint answer in the world, but if it doesn't work with the structural engineer's plans and the cathodic protection plans, then it's pretty much useless. So we have to make sure that we encompass as many field unknowns as we possibly can and really work together, especially on the projects to get thrown that curveball. Um, many leads are found on a structure when many of these things are found out when nobody expects them to arise. We help the team to work through the situations, keep the projects moving forward in a technically sound way, even if it's not our plan A. We may have to go to B, C, or D depending on how things are going. We can help support the applicator certification. So train the applicator, hey, this is how you handle these products and how it works best. We can assist with training the QA personnel at the field office. And we manage a quality assurance paint testing program where we test every batch of paint and solvent before it goes on our structures to ensure that we're putting on the best materials we can. Our role is technical, but it's also really hands-on and field-based. We try to bridge that gap between the ideal world of working in a laboratory and writing this perfect specification with the reality of working in a lock chamber or on a hangar construction site where things aren't as perfect as we would like them to be all the time. So we really try to be help and a one-stop shop for coatings, whatever the customers need, and to be there to support them through whatever curveballs are thrown our way.
And so earlier you talked a little bit about failures. And so, can you tell us, how do you investigate coding failures and what insights come from those analysis?
Failure investigations are a lot like detective work. We start by asking what failed, where it failed, when did it fail, what changed when that failure did take place, and then we start digging into the details. We look at the coding system, the inspection reports if we can get our hands on them, the substrate service preparation, application conditions, environmental exposures, the cure, the thickness of the coatings, and the service history. What conditions have these coatings endured? And we really take all of those pieces to try to formulate the best answers that we can. And then also, how do we fix it from here? What do we do now? In the lab, we can evaluate many, many, many different characteristics. And I've actually had numerous projects cut off a chunk of steel with a coating on it and ship it to me, which is very funny when you get a piece of sheet piling in the mail. Um, we can look at things like dry foam thickness, adhesion strength, surface profile, cross sections of the coatings to see if the layers are uniform and homogeneous. We can do other things in the field where we look for patterns. Is there something happening on the edge of these members? Are the failures isolated to one member? Is it all around welds or bolted connections or in wet, dry immersion areas? So really, we try to zoom out, look at patterns, and put all the details together to paint a bigger picture. The value of failure analysis is not just identifying what went wrong on this one particular project with very specific conditions. The bigger value is then feeding those lessons back into better specifications where we help to make these unified facilities guidance specifications that the DOW uses to write contracts stronger. And we use these things we learn from the failure investigations to provide better training, better inspection practices, and we also use it to formulate new research ideas. Why is this important, and where does this matter? Every failure teaches us something, and ideally, we can use that information to prevent that same issue from showing up somewhere else within the DOW.
And again, all of that investigation rolls back into that feedback of, this is how we're learning, this is how we're changing. And at the end of the day, we are saving the taxpayer dollars, because we are extending this life and understanding why it failed, so it doesn't happen again. So you talk a lot about testing. So I want to ask you specifically about batch level testing and how important that is for hydraulic steel structures.
For our hydraulic steel structures, these coatings are not decorative. They're not out there to make things pretty. Although that is a nice side effect, that is not the goal. And the cost of them not performing is extremely high. Quality assurance testing at the batch level gives us confidence that every coating and solvent or thinner material intended for the use on these structures meets the requirements of the specification before it goes into service. Paint is manufactured in batches, just kind of like when you bake up some cookies. Even when a product has the same name on the can, we need to still verify that the material meets the specification. And we often get the question of, why are you still doing this? These are commercially available products in many cases. Well, the answer is because we still see a 5 to 10% failure rate across our products that we use all the time. We look at properties such as viscosity, weight per gallon, the solids content, the pigment content, drying characteristic, color variations, and other performance-related requirements depending on the coating type we're working with. This is especially important for our USACE vinyl coatings because they are USACE formulas, meaning they are our recipe. We wrote the cake baking recipe, and so we know that we need to have this much oil and this many eggs in the recipe, and if that is in there, we know the products are going to work as they are intended to, assuming it is applied properly. It's much easier for us to reject a bad batch in the lab rather than to discover a problem after it's been applied to a structure in the field. Because mobilization in a lot of the places we conduct work, it's expensive and challenging. As I mentioned, painting one gate can be upwards of $1 million, and most of our structures have dozens of gates, sometimes more. It just depends on where we're working and what we're doing. We also are going to coat and retain panels from every vinyl batch that we test, and we keep those in our immersion tanks forevermore. And that way, if a problem does pop up down the road, we can go back and pull our panel and we have a comparison and a baseline. So we're able to say, oh, well, our panel does show that same stuff. So let's do some evaluation on what happened here. Or if we're not seeing that, maybe we can isolate it to like a contamination issue or something that went wrong with some methodologies in the field. It really gives us an important data point to figuring out the root cause of what occurred in the field. Batch testing can also sometimes identify issues that manufacturers may not know even exist. As an example, last spring, we had some coal tar epoxies, which we test all the time. And all at once, something shifted in the industry. And the three largest manufacturers that USACE obtains material from all began failing every batch we saw. And we were the red flags were going up, right? These coatings were not curing properly as they were intended to. Eventually, we did some investigative work and traced it back to a raw material. And that raw material is coal tar pitch. So it's basically just one of the ingredients in your cookie recipe. And this is a great example of the manufacturers didn't change anything on their end. There was nothing changed in the procedures or the packaging. Everything was exactly the same, except for that raw ingredient had some chemical changes that really impacted the way the product cured. So it's a great example of why this quality assurance testing matters and the quality it still does provide to USACE.
And without that batch testing, it could have gone on the hydraulic steel structure and failed and cost even more money. And so the cost savings of doing the batch testing ahead of time ends up saving dollars at the end. And so, how, talking about that, because you talked about how industry has the recipe, they know how many eggs, how much flour is going into it. So, tell me how your team contributes to the national coding standards and the specifications that recipe.
Sure. Our team is heavily involved in standards and guidance criteria that control how the coatings are selected, tested, specified, and applied in the field. We maintain and support USACE painting criteria such as UFGSs, which are Unified Facilities Guidance Specifications. And I serve as the SME or the subject matter expert on all of the '09 UFGSs for coating infrastructure. And then I'm the preparing activity where like the lead reviewer of the ones for civil works, such as UFGS 099702. We also participate in many industry organizations and standards groups such as AMP, ASTM, MPI, and others that are then cited in those guide specifications. That involvement is really important because USACE has some pretty unique infrastructure and we do not operate in a vacuum. We need to understand where the coatings industry is going and what products are changing, what test methods are being revised, and how the national standards affect our work at the project level. The benefit is a two-way street. We bring USACE field experience to national standards discussions, such as AMP committees, and we bring industry knowledge back into USACE guidance, such as, hey, these new products are being rolled out at these conferences, and we need to really look into these. These may have great benefit to the DOW. This makes our criteria more technically sound. It makes it more practical for use, and it just makes it more aligned with the realities of what's going on throughout the industry.
And so earlier you talked about how the one of the sticking points is how it's actually being applied. So tell me a little bit about how the role the Paint Technology Center plays with training to ensure that these coatings are being properly implemented during construction.
Sure. Training is huge, and it's honestly one of my favorite parts of my job. A coding system can be excellent on paper, the best formula manufactured in the top way, but if that paint material um, doesn't work in the field due to poor application, overall it's still a fail. And so we need to make sure that things align and that we know how to handle the products properly to ensure that they're going to perform. Surface preparation, environmental conditions, mixing, thinning, spray technique, stripe coating, film thickness, recoat windows, cure times, all of these things really matter in the overall performance long term of these coatings. Coatings are very sensitive to workmanship and field conditions, so we have to get it right to make sure they're going to work. I get the opportunity to teach Prospect 084 with a great team of instructors quite twice a year on paints and coatings. And this course really focuses on, the basics of paints and coatings, how to inspect them. And I also get to help out with Prospect 009, which is the corrosion course, really driving home how the coatings are the first line of defense against corrosion. I enjoy these classes because they give me a chance to meet these district personnel as people, talk to them about the problems they're facing in the field, hear and see what they are seeing in their districts, and help connect that spec language that I help to put into the UFGSs to what's actually going on in the field. For example, a line maybe have some gray to it. Well, that's never a good thing for USACE or the contractor. So learning from all of these different districts on what's working well and what isn't helps me to do my job better. The connection is especially important right now. The last year as a federal employee has been different, right, for all of us, and we have lost a lot of expertise in many areas. Training is the one way that we can help support the field and to bridge that gap to make that connection stronger. And we want people to understand it's not just what the coding requirements are, but why those requirements matter. For example, strike coding the edges and welds may seem tedious and kind of honestly annoying to the applicator. But those are often the exact areas where we see the coatings fail first. When people understand the reason behind the requirements, why they exist, they're much more likely to recognize why it matters and when something needs to be elevated before it becomes a costly problem.
And so, looking forward, where do you see the biggest opportunities for innovation in coding science?
Over the past decade, coating technology has continued to move toward better durability, lower environmental impact, improved worker safety, and more specialized performance, right? The chemistry behind paint is no longer some lead pigment thrown in fish oil slapped on a fence, right? It's much more high performance and much more formulated now. So we've seen improvements such as these high solids coatings, which really reduce the VOCs or volatile organic compounds. We've seen new technologies like polysiloxanes or fluoropolymers and just more advanced coating technologies that can do more with less coats and be applied thicker and work better with less in labor upfront. For USACE, one of the biggest impacts is not just the coating chemistries itself getting better, it's the ability to better evaluate the performance through testing, inspection, and data analysis. We're getting better at understanding why coatings fail, how that surface preparation affects that long-term performance, and how to match a coating system to the actual service environment. There is not one best coating on the market. It's the best coating for each environment. And the challenge is that the new technology does not automatically mean better for every application. Our job is to evaluate where the new technologies make a lot of sense and where a proven technology may still be the right choice, even if it is an older technology, but works well.
Well, thank you so much, Brooke, for your time today. And I want to thank you for being part of the Power of ERDC podcast. I also want to thank our audience for listening, or if you're watching this, and if you want to learn more about Brooke's research or the Paint Technology Center, visit links in our show notes. Explore additional episodes and learn all about our research at poweroferdicpodcast.org. Poweroferdicpodcast.org. Thank you, and until next time, we'll see you then.